Hi, this is János, it's Real World Audio, and we are continuing our exploration of WinISD, which is a computer modeling software to help you figure out the workings of a loudspeaker cabinet. And this software only works for your woofer, or if you use it as a full range driver, so you cannot put in a tweeter, woofer, mid-range, 3-way, 4-way, something. It's just for the base cabinet or a full range cabinet. Now what we are doing is we are exploring the Fostex FE103 Sigma driver, which is the driver that Jean Hiraga used for LePetit. And as you see, WinISD gave us a by default model for a 4-liter size cabinet tuned to almost 90 Hertz. And that's where we left off at the previous part. If you want to know how did we get there from ground zero, watch the previous video. Now, continuing, when you click on the Vents tab, here it tells you about the port. So you can give number of ports, so means we have one port on the loudspeaker, but you can give 2, 3, 4 ports, and it will calculate the tuning frequency based on the number, shape, and size of the ports. So this is what we have. So shape, we can change between square shape and round shape. So if it's square shape, basically, then you can design a slot port. It doesn't need to be a square. Much better if you flatten the square so it's a slot. And then you can design it the slot by how, let's say 10 centimeters by, and you can also enter a value by 1 centimeter. And then if you have this big port, 10 by 1, then you need 6.75 centimeter long port to have this type of tuning frequency. And let's see, let's go back to the box itself. So 4 liters, 89 Hertz tuning frequency. So what happens with the output? That's at about 91 dB, and starting around here, where is it now? So if you click there, then it will show you what is the frequency. For that, you can read the frequency there, 134 Hertz, and the output there is 90.916 dB. So we are dropping from, let's see, when we are here, it's 91.333 dB at 475 Hertz. So from there, we did a little dropping by here, and then it drops quite a bit more. So at 100 Hertz, we are already down to 88.8 dB. So as you see, as we are getting closer to the tuning frequency, we are dropping more and more and more, and we are, so sometimes there's a glitch in WinISD, and because this is the beta version of the software, and when this happens, you don't get right frequency and dB values. It's just minus 0.9 Hertz and minus 1 dB. So then you get some relative values and compared to the previous position. And it's kind of annoying, but it's very easy. So just you choose a different window, and then you go back to SPL. We were in the SPL tab, and now it's fixed. Now it comes back. So there are some minor glitches. That's the price you pay because you didn't pay for a full software. This is just the beta version for free. So basically, when we look at 89 dB, where is it? 89 Hertz, 87 dB. So actually this is a little bit more than 3 dB loss, so the modeling doesn't give us exactly the minus 3 dB point, but something roughly that you can expect, but it can vary a little bit. So what if we change the tuning frequency? We can manually adjust here either the box size, the cabinet size, which is the free air volume. It's not the outside measurements of a cabinet. You have to take out from the outside measurements all of that space that the cabinet, the wall itself occupies. That does not count into the volume. So the volume has to be the inside of the cabinet. That's the cats playing. And the tuning frequency, let's see if we change it from 90 Hertz. Let's say we change it down to 80 Hertz. How does it change? Then you see that it starts dropping sooner. But we cannot really see too much, can we? So let's just go back to that 89 Hertz. And let's just make a copy from this. You can do copy project, and now it says copy. And this copy, let's give it a different color. Let's make it blue. Okay. So now let's change the tuning frequency to 80 Hertz, and you see now that the blue line starts dropping earlier, but there's a point here. Let's click on it. And it's at 88 Hertz, where it starts to be on top of the red line. So basically, if you have the same free air volume cabinet and you tune it to a lower frequency, it means that the deeper bass you are going to get higher output for the low frequencies, but in the mid bass you are going to get compromise. You are going to get lower output compared to the higher port tuning. And that's because of laws of physics. Your driver puts out the same amount of energy regardless of where the port is tuned. The port tuning will change where that energy will be released, at which frequencies. So basically, if you tune the port to a higher frequency, then you will divert the energies towards the mid bass, and if you push the port tuning frequency lower, then you will divert the energy to the deep bass. So that's how the port tuning frequency choice weighs on you. And what else is going on? So now we tuned it almost like 10 Hertz lower. What is the difference? Let's look at the vent, at the port. So you see now for that lower tuning frequency, we need a roughly 9 centimeter long port. And with the higher tuning version, we need a 6.75 centimeter long port. So as you see, the deeper you tune the cabinet, the longer port you need to achieve it. And however, what you have seen is that we have lost quite a bit from the mid. This is like the mid bass, this region, and this is the upper bass. So like top of the mid bass, upper bass, a little bit lossy. And really, we are not getting that much deep frequencies either. The whole thing just rolls off, and here it's a little bit less roll off than there, but not really enough to make a really big difference. So what can we do about it if we want these tiny drivers to give us bass? Because right now, let's have a look at it. Let's have a look at this point. So both of these drivers, when we look at 500 Hertz, it's a nice place to reference the loudspeaker output. We are getting almost 91, here you can watch, 91.3 dB output. Now let's look at the minus 3 dB point. So that would be 88.3 dB. Let's just go there, just click lower and lower. 88.4, 88.25. So roughly at 96 hertz. So at 96 hertz, we are 3 dB down with the 90 hertz tuned port. And let's see where we are 6 dB down. So that would be 85.3 dB, 85 point, roughly there. It's at 82 hertz. So basically this cabinet will give us a bass extension down to about 80 hertz. That's the minus 6 dB point. And below that it's not going to do too much because it just rolls off way too high. When you have a bigger cabinet and the roll off is happening below 60 hertz or so, then you can even look at the minus 10 dB point. That's my generic point that I look at for useful bass output at minus 10 dB, because your loudspeaker placement and your room is going to help out with the low frequencies enough that minus 10 dB point will give you in your room a working level. Of course, when you put it in an anechoic chamber, the minus 10 dB will keep you very much lacking at that frequency, but in your room it will play nicely. However, here we are too high on the frequency range, so here even the minus 6 dB will be very much noticeable because it just starts dropping way too early, way too soon. So what can we do to improve this situation? Because as you see, when we started going lower with the port tuning, we are just losing mid bass, and it's a little bit, we got something. Now let's tune it maybe like down to 60 hertz. What do we get? Oh, look at that. Here, this point, 84 dB, how many dBs down that is? That's like 7 dB down. That's when we start to see some gains there, but it's really kind of useless because it is just happening way too soon, way too high in the frequency range. But we have the whole mid bass missing basically. Just have a look here. Like 127 hertz, 88 dB versus 91 dB. So a 3 dB loss. That's quite significant loss of mid bass. So what can we do to change this situation? So what we can do is, let's just go back to that 80 hertz setting, and we start increasing the cabinet size, and let's see what happens. So instead of 4 liters, let's give it 10 liters. And now you see that we are starting to see something truly amazing. You see that there is still a drop in the mid bass, but instead of the whole thing starting to plummet like an axe into a lake, but the response starts rising, and we are getting really serious bass output. Now, if you put this into a small room, then your small room, the smaller your room, the frequency, the shorter frequency of your room is going to start the reinforcements already at higher frequencies. So basically, when you chuck your loudspeaker into a real world room, your room will start adding to the bass response at a frequency between 100 Hz and 200 Hz. If your room is a small room, that frequency is closer to 200 Hz. And what does that mean? It means that in a small room, from 200 Hz, the output of your loudspeaker will rise, will be higher and higher. And when you reach half the frequency, then you will get an increase in the output. That depends on how well your room is insulated from the nearby rooms in your house. So basically, if you have a perfectly sealed room that is like a vacuum sealed room, then you will get a 6 dB increase in efficiency, dropping from 200 Hertz to 100 Hertz. Now, that's only possible when you have a hermetic seal, such as you might have in some recording studios. In a normal home, the rise is somewhere around between 2 and 4 dB per octave. So basically, it means 2 to 4 dBs per halving of the frequency. So each time you go half the frequency, you add that amount of dB to the total energy output of your loudspeaker. And it's actually not the output of the loudspeaker, but that's the effect of your room. That's how much your room is reinforcing bass. And basically, just imagine that your room is like an aquarium. You have your aquarium here, and you start sloshing the water in your aquarium. And if it's a smaller aquarium, meaning smaller room, then the waves that start to get sloshing are shorter waves. So it starts, the slosh is at higher frequency, and when you have a bigger aquarium, like having a bigger room, those high frequencies don't get excited anymore, and you will have those longer waves forming in the room. Same thing happening with the air, as if it would happen with water as well in a pool. So coming here, as you see that there's a really big rise here. It's getting off the graph. So let's just adjust it. Let's go to our crowbar and increase the SPL from 92 dB to 95. So we can see where it goes. There you go. Now the whole thing fits in here, and it rises to 92 dB. So actually the output, the raw output of the cabinet, a loudspeaker cabinet, in this region, basically, which is at 87 Hertz, will be higher than the peak output of the loudspeaker in higher ranges. So basically, this will give you a loudspeaker that has a tremendous, well, not tremendous, but a significant mid-bass hump. So everything that has mid-bass in it, like a bass guitar, they will be really have like a big body to them, and really they will be prominent in the sound. Or if you have a basso singing, then he will overshadow a tenor or an alto female singing. The bassos will be more prominent. And however, what you can also do, that when you see this hump coming up, then if we tune the frequency higher, then this hump will be bigger. So if we tune it, you see 90 Hertz, the hump is even bigger, goes much higher than before. So it was 92 dB before, now it's almost 94 dB. It got 2 dB taller, but it crept a little bit more towards the higher frequencies. So it's even more boomy than before, but it starts rolling even faster. So where do we get the minus 6 dB point? So here we were at 91 dB, so 85 dB. Let's see, where we are looking at 85 dB, clicking on the blue line, and when you see that I click on it here, and it intersects the 85 dB line, and I read the frequency. There it is, 72.5 Hertz. So 72.5 Hertz is a minus 6 dB for this loudspeaker cabinet. So it means that basically this will be good to about 70 Hertz, 65, 70 Hertz. And it will be really mid-bass heavy, but below 70 Hertz, you will miss the bottom octave of the bass guitar and every bass instrument, but the top higher octave, higher range of the bass guitar will be super prominent and dominating the sound. So that's why let's just go the other way, and instead of increasing, let's decrease the tuning frequency. So now we tune it to 70 Hertz. Now we are getting somewhere. And as you see, we are getting roughly a straight line. There's a little bit of a valley there, but the energy of the driver does not just fizzle out, but it just gains energy before rolling off. So now what you see compared to the previous version, which was the one recommended by the software, 4 liters tuned to roughly 90 hertz, then it starts basically rolling off from here about, what's that, 130 hertz. Below that you will start noticing with your ear that we are starting to lose the bass. So basically if you have the basso, then the basso will be losing his voice compared to your tenor and compared to your altos. However, in the case of the higher volume, so we doubled from a little bit more doubled from 4 liter to 10 liter volume. We are still talking about baby loudspeaker size. In that case, where we start to lose the energy about this point, what is that? 70 hertz. So instead of 127 hertz, we extend it to 70 hertz. So we almost added an extra octave in the to the useful bass response of this cabinet using the exact same driver, just by doubling the volume of the cabinet and tuning it to a lower frequency. So when you read about loudspeakers, that's why size matters, cabinet size matters. And even if you have a tiny driver, it's the cabinet size that will impact entirely the bass response of the cabinet. And of course, there is no cheating the laws of physics. And as you see, the smaller cabinet with the higher tuning has higher response here in the higher mid bass, upper bass than the bigger cabinet. And it's because it's a smaller cabinet, it's tuned to a higher frequency, so it sings more in the higher frequency region. And what's the difference between them? The difference is the room selection. So basically, here you see that the bigger cabinet is already dropping a few dBs in the mid bass. And how can you use that for your advantage instead of treating it as a deficiency compared to the smaller cabinet? You can use it to your advantage by choosing a small size room. Because in a small size room below 200 hertz, your room is going to increase, to boost the output that you hear as the total response in your room. And even though the speaker's output drops, but because your room is adding more energy to it, keeping that energy inside, the actual response in your room is going to flatten out. And you are not going to notice a drop, but you are not going to notice that the energy is even. So basically, if you have this tiny, smaller version cabinet, you want to put this into a larger room. If you put it into a small room, it will sound boomy. So you will have too much upper mid bass, too much lower upper bass, and you won't have any deep bass whatsoever. So don't you just think that the smaller cabinets are just really good because you have a lot of mid bass, but you will have a relatively overblown mid bass in the small room and zero deep bass. And this other cabinet, the bigger cabinet, actually will work better in a small room than a teeny weeny cabinet. So you see, this is a little bit of a counterintuitive thing. You would expect that the smaller your room, the smaller your cabinet size need to be to fit. And this shows the exact opposite. Well, within a within reason, relatively smaller room can use like a smaller size cabinet, but I'm not thinking about like 5 liter versus 10 liter, but maybe like a 500 liter cabinet would be a little bit way too overblown for your room, that's for sure. That on that scale, it really makes sense to choose smaller size speakers for a smaller room. But within that size selection, if you go for a bigger cabinet for the same driver, then it will work better in a smaller room compared to the smaller cabinet size using the same driver. So now we are at 25 minutes. I am clicking stopping here, and we will continue from here exploring WinISD and the LePetit. Thank you for tuning in. Please like, subscribe, enjoy WinISD. Bye bye.